Hey guys, welcome. Today we are going to be going through our math for accelerated algebra 1. You guys are first going to go through proportions, similarity, dilations. We're going to stop the video. Y'all are going to practice some of that, and then we're going to go to similar triangles and practice some of that. Let's go ahead and get started. So, first thing we have is proportions. A proportion is an equation that sets two ratios. Okay, fancy word for fractions. Okay. So a proportion that sets two ratios equal to each other, we say something is proportional if their ratios are equal. So if they simplify to the same value, for example, 12 over 4 and 6 over 2 are proportional because if we reduce them, they are equal to 3 over 1. Knowing that proportions must be equal, we can use them to solve for missing values. To do this, we use a method called cross multiplying. Y'all sometimes have learned this as the butterfly method. We're going to call it cross multiplying. That is the mathematically accurate statement for it. To cross multiply, you're going to go diagonally across the equal sign and multiply. So our first one we're going to do is 12 times 4, and then we can set it equal to our proportion of 8 times x. We can then simplify these, so 12 times 4 is going to give us 48. 8 times x is 8x. To solve for x, we're going to divide both sides by 8 to get that x equals 6. Then we can go ahead and go to example 2 for this. We're going to solve for the value of x again by doing the exact same method. We're going to cross multiply, so we go across diagonally the equal sign. So 3x times 4 is equal to, and then the other side, 3 times 6. 3x times 4 is 12x. 3 times 6 is 18. Divide both sides by 12, so we get x is equal to 1.5. Again, guys, decimals and fractions are okay as answers. We don't have to always get a whole number like we did in example 1. Also, guys, if you had set it up that you did the 6 times 3 first, and then this other cross multiplying, the 3x times 4, you're still going to get the same answer. So it's not necessarily an exact order. You just have to make sure you're going diagonally across the equal sign. If you would like to pause, work through example 3, and then hit play to check your work. So we can cross multiply. We'll do 2 times 2x plus 4 equals 1 times 16. Distribute to get 4x plus 8. We're going to then move this 8 over by subtracting it from both sides. Then we divide by 4 to get x by itself to get our final answer of x equals 2. Something that's really great, guys, with these, you can plug this 2 back in for x and double check your work. Because we'll get 8 over 16 equals 1 over 2. Those ratios are proportional and equal. Looking at the next part, we can say similar figures. When they're similar, they have the same shape, but not necessarily the same size. Okay? So we can have two triangles, but one's a bit bigger or smaller than the other. One thing that's also required for shapes to be similar, these sizes or their sides are proportional. In other words, they have the same ratios. So we can look at these two triangles below that are similar. So we can say triangle ABC is similar to triangle DEF. And this little squiggly line is just telling us that they are similar, and which means their sides are proportional. We can set up proportions for their side lengths to show that two triangles are similar. To do this, we have to use corresponding sides. Okay, so above we have AB. It corresponds to side DE, okay? Because this one and this one correspond and are the same place in the similar triangles. AC is gonna correspond to DF, and then BC is gonna correspond to EF. We can then go ahead and write these pairs. So we have AB to DE. So that ratio of sides is going to be equal to the ratio of side AC to DF, which will be proportional to the sides BC to EF. Now that's a lot of letters. Let's plug in those side lengths to make sense of those numbers. So we can plug in the corresponding side lengths. So AB is 12. So 12 over DE, 4. We can do the same for AC to DF. So AC is 12, DF is 4. And then we can do the same for BC over EF. So BC is 15, EF is 5. If we simplify each of these ratios or these fractions, we're going to get 3 over 1, 3 over 1, and 3 over 1. So because all of the proportions are equal, the triangles are similar. Please note all of the proportions have to be equal, not just one or two of them. All of the proportions have to be equal. Once we can prove that they're similar, we can write a similarity statement. We're going to use, this is a tiny line for similarity statement, but we're going to use the symbol of a squiggly line. Just one squiggly line. The approximate value, also written here. A similarity statement for our example on the last page would be triangle ABC is similar to triangle DEF. The corresponding parts must go in the same order. So I did ABC, and remember ABC, it was 12, 12, and 15, and then DEF was 4, 4, and 5. So I did A, B, C. So I did short side, long side, short side. So I have to do the same thing here. Short side, long side, short side, and name the vertices in that order. So in example 1, we can now practice determining if triangles are similar and writing their similarity statement. So determine whether the triangles are similar. If yes, write a similarity statement. So my tip to you would always be find the smallest side and put it over the smallest side. Okay, so we have that ratio of 1, 2, 3, or 1 over 3. And then we can find our largest side, okay? So 25 is the largest on this one, 5 is the largest here. So we're gonna do 5 over 25. And then the last ones are gonna be your remaining. So then 3 over 15. Now, do all of these ratios simplify to the same fraction? So 1/3 simplifies to itself, 5 over 25 simplifies to 1/5, and then 3 over 15 simplifies to 1/5. Okay, 1/3 equals 1/5 equals 1/5. That's not true. These are not equal to each other, so it is not similar. So these two triangles are not similar because not all of the sides are proportional. Looking at example 2, we're going to determine if these two triangles are similar, and then we have to find the missing side if they are. Okay? So my first thing, I see this small triangle. Okay? So this triangle, I'm going to go ahead and just draw it out here so I can see it. So X and 9. Then we have this big triangle, and that means the sides are going to be x plus 4 and 12. So let's go ahead and draw that over here. I'm going to draw them over here. So this is 12, and this is x plus 4. Okay? Now, we're going to have to find the value of x to make these two triangles similar. So that means we're going to have to use our proportional reasoning to solve. So we're going to do this side of our triangle to the small side triangle. So we can do x over x plus 4. And it's going to equal the small bottom part of the triangle divided by the big bottom part of the triangle. Now we're going to use what we talked about with proportions and cross multiply. So we'll have 12x is equal to 9 times x plus 4. We then can distribute, so 12x equals 9x plus 36. We're going to have to subtract 9x from both sides, so we get 3x equals 36. Divide both sides by 3 to get our final answer of x equals